All right, welcome everybody. My name is Zach Snyder. I'm with the nonprofit Solar Oregon. We are gonna go ahead and get started with our webinar this evening, which is our How to Go Solar workshop, which is an introduction and a guide to solar and how to go solar for home and business owners. Really glad that you all can join us. I'm going to kick us off with a brief overview of everything we're going to be going through today. First off, we're going to be taking a look at how solar works. And then we'll be walking through how do you know that your home is right for solar? What makes a home or business a good site for solar? We'll then be walking through solar incentives that are available to help you bridge the cost, and we'll be ending with a Q&A. So I'll go over how to ask questions in the Zoom platform in case it's new to you, but this is intended to be a interactive webinar. So please, if you have questions at any point about any materials in the webinar or just general solar questions, feel free to ask those and we'll address those in the Q&A. Altogether, this should be roughly 25 to 30 minutes before the Q&A. So we might be looking at about a 40-minute webinar tonight. So I'd like to introduce Solar Oregon a little bit more. We are 40 years old. Actually, I think we're about 42 years old at this point. And we work to advance the adoption of solar and other forms of related clean energy in communities across Oregon. And we do this through educational events like this How to Go Solar webinar. We also host solar home tours, including an annual zero energy homes tour called the Go Zero Tour, which is about zero energy design, which incorporates both solar and energy efficiency. We also host Solarize campaigns, and we are hosting a Solarize campaign in the community of Hood River in the upcoming couple months here, which is pretty exciting. And more generally, we just create community and create connections to help people explore solar and figure out how they can incorporate it into their own life. We are a member-based nonprofit, and a huge thank you to everybody who is a member on the webinar tonight. If you're not a member, please consider being one. It's a really great way to support us and support this education that gets solar installed in our state. So if you care about clean energy, you care about the benefits that has to people who are saving energy, both homeowners and business owners and nonprofits and all of the above. So if you care about that, please become a member. You can also donate. You'll see the link on the right here, bit.ly/donate. I'm going to go ahead and drop a number of links in the chat that I'll reference. So if you click on the chat icon on your bar of buttons in the Zoom platform, you can see all the links I just dropped in there that include this link. So, and you can follow us on social media at Solar Oregon. Also, I'd like to introduce the Energy Trust of Oregon, another really great nonprofit. It's been around for a while. Energy Trust of Oregon provides incentives and supports programs like this that help to increase the sophistication of our usage of energy in Oregon, including supporting renewable energy and energy efficiency. And they serve all the customers of Portland General Electric, Pacific Power, Northwest Natural, Cascade Natural Gas, and Avista. They support a number of programs that Solar Oregon produces. So big thanks to Energy Trust of Oregon. And before we dive into it, just a little refresher on Zoom. You'll see the chat icon, which is flashing in this image here. You can also see the Q&A button that has a Q on this box. And at any point during the presentation, if you have a question, I encourage you to put that in the Q&A box, not in the chat. though I will try to catch any questions that are in the chat after we get through the ones in the Q&A box. Finally, I've got a couple of polls, and I like to use polls in our webinars to get a sense of who you are, where you're coming from, and also we have a poll at the end that will ask you what you liked about the presentation. So I'm going to launch this first poll, which is asking where you're tuning in from. You can see that there are a number of options: Portland, Willamette Valley, more broadly, Oregon Coast, Eastern Oregon, Southern Oregon, another state. Go ahead and click your choice and then hit submit. Looks like you guys are pretty quick. We've got almost everybody. Just give 1 second. All right, let's go ahead and looks like we've got people mostly in the Willamette Valley, including outside of Portland and a little bit in Southern Oregon and another state. So welcome, glad to have all you. Going to also share a poll on demographics. This is completely anonymized, voluntary information if you wish, and it helps us to understand who we're serving. So go ahead and take a minute or two to fill that out. Oh, Sam, I see you're from New Orleans. Great to have you on the call. I always wanted to visit New Orleans. I'll just give 1 more minute here. All right, I'm gonna go ahead and close this. And then, sorry, I have 1 more poll for you, and this is the one that we're most interested in. What we do in this webinar is educate about the incentives that are available. So these 2 questions are just asking if you're familiar with the Energy Trust of Oregon standard solar incentive. That's the first one. You can just answer yes, no, or if you're not sure, you can click that. And the second one is, are you familiar with Energy Trust's solar within reach incentive? So if that sounds like gibberish, you can just click no. I'm gonna give just a minute here so you can answer that. Thank you for all these responses. All right, gonna go ahead and wrap this up. And looks like most people have not. So hopefully we will fix that by the end of the webinar. And I think we're about ready to get started. I have the unfortunate situation that my Zoom bar is blocking my ability to get rid of this polling screen in front of me, but that's all right. All right, so let's dive into how solar works. So this diagram is just going to show you the 2 main parts of a solar system. One is the solar panels, which you can see over here on the upper left, also called a photovoltaic panel. You'll see a bunch of little cells on there. You may see that on an actual panel. Some panels just look dark black, like a flat screen TV. The sunlight hits that surface. It creates a voltage of electricity, which is what you're going for. It creates a type of electricity called DC electricity. And you might remember from grade school that there is AC and DC electricity. Your home uses AC electricity. And because the solar panels produce DC electricity, we also have to have a piece of electrical equipment called an inverter or a microinverter, which those are 2 things that perform the same function. and they just convert that electricity from DC to AC. From there, it goes right into your home's electrical panel, and that's your breaker box that you might have in the garage. And from there, it powers all the circuits in your home, your lights, your refrigerator, your jacuzzi, what have you. And additionally, electricity, you can't really control where it flows if it's on a bunch of connected circuits. So when you're producing more solar than you need, that energy flows out of your home, out through your utility meter and back onto the electrical grid. You may have a meter right now that only records the electricity that you consume from the utility. When you go solar, your utility company will come and swap out your meter and give you a bi-directional meter that can measure the electricity flowing in both directions. And that will allow you to get credits for that electricity that exits your home. We're going to talk about how that crediting system works in just a second. But that's basically it. It's relatively simple. Here's a look at the inverters. So this is the box that converts from DC to AC. On the left, you'll see this white box here, and that is the inverter. Alternatively, you can see on the right, this is just a ground-mounted solar installation. And this is the underside of the solar panels. You can see these black boxes here, and there's a black box for every 1 or 2 solar panels. And they are performing the exact same function as the white box on the left there. Whether your solar contractor, when you are installing on your home or business, suggests an inverter or a microinverter, they have some characteristic trade-offs, and your installer should know what is a good option for you. Here is a look at a couple of different mounting options for solar. So I would say by far the most popular, especially in a dense urban area, but also in rural areas, is a roof mount solar system. And that's because your rooftop is just sitting there, and it's a great place to do something useful for you. And the system on the right that you see is a ground mount, and that can be in any open field or space. Typically, you want a fair bit of space for that. The advantage of a ground mount is if you wanted to re-roof, you wouldn't have to take your solar system off the roof, re-roof, and then put it back on. The disadvantage of a ground mount is that you have to trench from the ground mount to your home so that you can run a wire to connect to your electrical panel, which can increase the cost of the installation. But both of these are great options, and they are used frequently. So here is the system called net metering, which is the system of how you get credits for the solar energy that you export to the grid when you have more solar energy than you need. So on the left, I've got a couple of bar graphs here. On the left, you'll see a graph that shows a typical situation in a sunny summer month. So the height of the orange bar is how much electricity your solar system is producing over the course of that month. The height of the blue bar is how much electricity you're consuming with all of your lights, refrigerator, appliances, etc. You can see that in a sunny summer month, you might expect that what you're producing with your solar system exceeds what you're consuming. In that case, this green arrow represents how much excess you produced, and that is something you get credit for. It's called net metering credit. On the right graph, you can see that it is maybe a gloomy winter month, December, January, February. You're producing less energy with your solar than you have consumed over the course of that month. And you can see this red arrow shows you how much you essentially owe the utility, right? That's the excess electricity that you had to buy from them. The great thing about net metering is you can take the excess that you produce in sunny summer months and use that to offset what you're consuming in the winter months. And if your solar system is sized to match your energy needs, then over the course of a year, you can essentially roughly break even. So these credits roll over from month to month, but something to note that's important is that they do not roll over from year to year. The net metering calendar year starts on March 1st in Oregon. And so you'll start to build those credits in the summer and use them in the winter, and then forfeit any extra if there is at the end of the year. So that is a basic look at what is solar and how does it work. And fortified with that knowledge, let's go ahead and take a look at what makes a home ideal for solar. And just to give you some context here, a lot of homes, maybe you'll have trees, maybe you'll have a building shading the roof, in which case you won't have enough sunlight. Maybe if it's an older home, there could be a roofing or a structural thing that you want to take a look at. Most homes can support solar some way, somehow. Shading is probably the biggest thing that affects that. But also there can be extra cost to overcome some smaller barriers. So let's take a look at what those are. So the first thing to note is how you size a solar system. And solar is incredibly flexible. You can have a system, technically, that's just one solar panel. You won't really see that on homes. Typically, a residential solar contractor will sell you at minimum probably around 6 panels, and that's a pretty small system. For a residential system, you might see on the large side, you might see up to 40 solar panels. 30 or 40 is a pretty big solar system. And so what affects how you size the system? The first and foremost, you want to make sure that your system is matching your energy consumption and not exceeding it. And that's because of what I just told you with regard to net metering, that your credits roll over from month to month, but not from year to year. And so you can't just create a big power plant and sell a ton of electricity and be rolling in money through net metering, unfortunately, even though net metering is still great. Typically that's a constraint. And so a solar contractor typically won't try to sell you something that is bigger than what you're expected to use over the course of a year. Other factors that can affect the size are available space. Maybe you don't have enough roof space to quite hit all of your energy needs. In that case, you would offset a portion of them, and it still turns out to be really useful. Budget can also affect it. Maybe you want to invest in a partial size of the system now, and then later increase the size of the system. That is possible, and people do it not infrequently. You do want to make sure that your inverter is sized to allow you to add your additional solar panels at the least cost. So if you're planning on that, just talk it through with your solar contractor. And finally, some HOAs or historic districts may have rules about not putting solar on the front of the home that's facing the street for aesthetic reasons. I happen to think that solar is beautiful, solar should be cherished, but that may be something that restricts your ability to install solar where you are. A couple of fun facts about system sizing. It's measured in kW, which is kilowatts, and that's just a nameplate rating for the general capacity of the system. Don't worry too much about what that actually means unless you're an electricity nerd. The average size of a system in Oregon is roughly 6 kilowatts. So next, we're going to take a look at how much solar access do you have? And by solar access, we just mean how much sunlight do you have that you can take advantage of with solar. And so these diagrams on the left and the right just show the same exact thing. This is the orientation of a house with respect to the cardinal directions, north, south, east, west. And that's important because we're in the northern hemisphere and the sun travels from east to west in the southern sky, which means that south-facing roofs are ideal for solar. East-facing and west-facing roofs also work great for solar. North-facing roofs typically do not. Sometimes, especially in the Willamette Valley, this may not be as big an issue if you're east of the Cascades, but in the Willamette Valley, where we have misty mornings, you might see that a solar system, you really want it to be just south of east, though due west is typically just fine. So that is where you're going to get the most sunshine, and that's where you're going to want to place your solar panels. The next thing we're going to take a look at is the roof, and the roofing material can have a slight impact. These two roof types that you see, which are, I think, far and away the most common roof types, are both great for solar. Asphalt shingle, incredibly easy to install solar on. Standing seam metal, even easier and better. So there are some rare roof types like metal shingle that are hard to work with for the installers that may add cost, but it is pretty much feasible to add solar on any type of roof. Just some rare ones may add extra cost. However, the roof condition and age is significant. And this is because, as I mentioned before, if you need to re-roof, you need to take the solar system off and then put it back on. That's something that an electrician needs to be involved in. It can cost a couple of $1,000s, potentially a few $1,000s. It's a service that many solar contractors will offer, sometimes even if they didn't install the system. However, the best thing to do is to make sure that you re-roof if you need to before you get solar. Make sure you have at a minimum 10 years of roof life left before you go solar. And that is the way to maximize your investment there. And finally, just a note on the roof structure. This is important not because solar panels are heavy and they create any kind of dangerous downward force, but the solar panel actually rests several inches above the roof. And as the wind blows across your roof, it actually creates a shearing force that pulls the roof slightly upward. Totally manageable for most roofs. However, here's what you need to know. The image on the left is an attic where you can see trusses. And what that means is you have these cross beams, both vertically and horizontally up at the top. You can also, if you take a close look in that image, see the metal plates that are holding the cross beams onto the main rafters there. And that will tell you that these are prefabricated trusses. You are A-okay, you'll have no issue with solar whatsoever. On the right, you'll see an image of an attic with rafters. You won't see any support beams vertically or horizontally. And rafters are generally just fine too. Where you may need to either hire an engineer, which a solar contractor would handle, but it can add extra cost. You may need to get some engineering done and maybe even some structural reinforcement if those rafters span too far of a horizontal distance. And so a solar contractor will take a look at your attic and make those measurements and figure out if that's required for you. So hopefully that gives you a good sense of the types of homes and businesses, the facilities, the sites that are best to install solar on and least cost to install solar on. Now we're going to take a look a little bit at the financial side of solar. The first thing that I like to point out is the trend of lowering prices. So this is a graph over the past 10 years, and that orange line plots the average cost of a solar installation nationally. And you can see that the price has dropped significantly as the industry has grown significantly, and it's continuing to grow significantly. You can see the price drop is kind of leveling off slightly, though continued price drops are expected in the future, kind of continuing that trajectory. So this is great news for you. there are great incentives available. So there is on the federal level, a solar investment tax credit. That is not a tax deduction, but a dollar for dollar tax credit. That is up to 26%. There is a solar and storage rebate, which is up to $5,000 for a solar system and up to $2,500 for a battery or a storage system attached to a solar system. That is in Oregon. That is a state rebate, and that's right up front. Your solar contractor applies for that and receives it on your behalf, and you don't pay that cost. And finally, there is an incentive through Energy Trust of Oregon that is available to people in the main big utility company areas that we have. So if you're a Pacific Power customer or a PGE, Portland General Electric customer, you can get access to this incentive, which is either $1,200 in Portland General Electric or $900 in Pacific Power. And in addition, Energy Trust of Oregon offers an incentive called Solar Within Reach. And this is for folks who are income qualified. So for example, a household of 4 residents, if they earn collectively less than $99,934 per year, they qualify for this incentive. And this incentive is substantial in Pacific Power territory. It's a certain dollar per watt rate up to $4,200. In Portland General Electric territory, it's up to $8,400. And if you're wondering at what size of system that incentive maxes out, it's at that average 6 kilowatt system size. So if you have an average size or larger solar system, you'll get the full incentive value there. So this can be really significant. I encourage you to explore this, make sure that if you qualify, you take advantage of this incentive. So, and this is where I'm going to want to, and I apologize, try to get rid of this polling bar that I have on my screen that is stubbornly, I don't think you guys can see it, it's just on my screen. So, I might have to, oh, there we go. Okay, perfect. These next 2 slides are typically the most popular slides in the presentation. They are sample budgets for Portland General Electric customers and for Pacific Power customers. We're going to take a look at an example budget for an average 6 kilowatt size system. And I am excited to share this example budget with you. Just note that you should take it with a grain of salt because system costs can vary widely for some of the factors that we've already discussed. So, but let's assume that our upfront cost of the system before any incentives is $20,000. So you'll see in the middle column, the cost of the system as each incentive is applied for a non-income qualifying family. And then for families that qualify for the low to moderate income rebates or incentives, you can see on the right column the prices there. So we start at $20,000. We applied the Energy Trust incentive. So in Portland General Electric, that would be $1,200 if you are not income qualifying, or $8,400 if you are. That takes the net cost down to respectively $18,800 or $11,600. Then the Oregon State rebate is applied. Actually, I have to edit this cell here. It's supposed to be $5,000 for either of them. That takes it down to roughly $15,000 or roughly $6,600. And 26, so that is the out-of-pocket cost of the customer. You can see that the Solar Within Reach incentive for Energy Trust of Oregon makes a huge difference. And that is the difference, most of the difference there between these two. out-of-pocket cost examples. Then the following year, when you file your taxes, you can take the 26% federal tax credit. So you won't get that immediately, but you will get that the next year. And that is applied there. And the total cost comes down to roughly $12,000 or roughly $5,000 if you're income qualifying. That's Portland General Electric. Let's take a look at Pacific Power. I'm not going to run through all the same things, but I'll hit the highlights here. We start at $20,000 again. The Energy Trust incentives are applied. That takes it down just a hair for non-income qualifying families. Takes it down a good little chunk to $15,000 if you are income qualifying. The out-of-pocket cost is roughly $15,000 or $10,000 if you're income qualifying. And then after that, federal tax credit takes it down to roughly $12,000 or roughly $8,000. So hopefully this gives you a good general sense of the cost and what you can expect to pay for solar, and also the importance of incentives here. So finally, how do you get started if you are ready to go solar? We have some recommendations for you. So if you are in Energy Trust territory, that means Pacific Power or Portland General Electric, you are going to want to take a look at Trade Allies. This is a network of solar installers that has been ranked and vetted by Energy Trust of Oregon pretty thoroughly. And they have a great tool called the solar bid request. And if you go into the chat again and you go to those initial links that I dropped in there, you can see the link here. You can also Google Energy Trust of Oregon solar bid, and this should come up. You'll see a screen like what you see in the right half of this slide. Request your custom analysis and bid. This is an online tool. It takes about 5 minutes or less to enter your information in here. And Energy Trust of Oregon essentially pseudo-randomly selects 3 of the highest ranked contractors in your service area and gives them your information for them to get in touch with you to offer you a free quote for solar. This is great because you get multiple quotes and it's a very easy, quick tool to use. And you know that the contractors who are getting in touch with you are going to be high quality. Once you've done that and you've compared your quotes, you figured out the company that you want to go with, and you've signed the contract. Once you sign that contract, it is a turnkey service. So solar installation companies will cover, they will handle everything. They will handle all of the permitting, the design. They will get it on their construction calendar. They may be booked out, especially with supply chain delays during COVID. Some contractors are booked out several months even right now, but they won't be on site during that time. Once they actually come to your home to install, it'll just be 1 or 2 days that they're installing there. After that, your contractor will manage the inspection with your local jurisdiction. They will manage the swapping of your meter for a new shiny bidirectional electrical meter. And they will manage the interconnection process with the utility. And once you are interconnected, they flip your system on. And from that moment on, you are producing clean energy on your rooftop or your ground mount or wherever you have those panels. So that is the process for going solar. Again, check out those links that I put in the chat at the beginning of the webinar. And we are ready for some Q&A. And I will love to take all of your questions. Before we do that, I have one last poll that I would like to launch right now. This is really helpful for us. This is just a post-event survey. And just ask you a few questions. For example, did this webinar effectively explain the Energy Trust standard solar incentive? Did this increase your interest for solar for your home and business? Things like that. So please take a couple minutes. And at the same time, if you want to put your questions in the Q&A box, and we'll get to that. I'll even take a look in there right now and see what we've got. Oh, Peter, glad you're on the webinar, and thanks for this info in the chat. The income, my slide was out of date. The income level has gone up. So this is for the Solar Within Reach incentive. The threshold for a household of 4 is now $106,944. So that's really why they call it a low and moderate income incentive. And Peter, you also point out the income levels are lower for the ODO grant. And that is a really great point there. Julie, I'll get to the questions in the Q&A box before we get to the ones in the chat. So I'm just going to jump in here. And I'm going to put my contact information on the slide too for you there. So Mopsy, you ask, will this program be available to review or share later? I have a friend who's interested but unable to see it tonight. Absolutely. First off, there will be a recording. This is being recorded, and you'll get that in your inbox in the next 24 to 36 hours here. So take a look for that. You can also go on our YouTube channel, Solar Oregon on YouTube, and we have tons of recordings of a lot of webinars we've done there. In addition, we host this webinar frequently. So there's an opportunity to join in and to ask questions too, if your friend would like to do that. Lindsay asks, have you heard of a solar contractor denying an installation / incentives because the roof is a hip joint roof? I live in Portland, and Ion Solar did a pre-contract inspection and denied us, saying the city of Portland would not allow solar installed in a hip joint roof. We have not reached out for a second opinion, nor have we done any research. That is a great question. And I believe that a solar contractor who installs in Portland may be a better source than myself, because specific aspects of Portland code, contractors know those like the back of their hand. I know them, a lot of them relatively well. Hip joint roof, I have heard that before, but I was not aware of a rule of not installing on hip joint roofs. However, I do trust Ion Solar that they know what they're talking about. If you are concerned about it, I would say reach out to another highly rated Energy Trust of Oregon trade ally contractor. You can go on energytrust.org and use their Find a Contractor tool, and you can find everybody in your area. You can search by zip code and just call up one who has a high star rating and just ask them, and they should tell you. Ed Riley, a contractor told me the net metering credit might be going away. Is that the case? That is a great question. Net metering, first off, many states have net metering programs, and net metering programs sometimes change, sometimes significantly. California is currently in the process of working out an update to its net metering, and I think a lot of people have it on their mind because of that, because a lot of policy involving solar typically starts in California and then propagates out. And it is true that there are always forces in a state that do not like net metering, and who are trying to get rid of net metering. That's been true for years and years in Oregon, and I don't see an imminent threat, though people sometimes do imagine threats, I think. Hopefully that answers your question. Masa, you ask, the roof truss of my 70-year-old home may not be durable enough for solar panels. The assembly is a bit sketchy. Would you recommend Tesla solar panel, which is incorporated within roof shingles? Great and interesting question. Tesla, so the first thing I'll say about the roof structural requirements, Portland is different from a lot of other jurisdictions in Oregon. Portland is very restrictive in what it allows, and many jurisdictions, you can have a home that may be relatively, you could call it, what do you say, not durable or relatively sketchy. And it should be just fine functionally from a structural perspective, but Portland makes you double dot your I's and double cross your T's when it comes to that structural requirement for solar. So it may be that if you're in Portland, that it would have an effect on whether you would pass permitting. In terms of whether Tesla solar shingles are and I think that's what you're getting at here is the shingles, not their solar panels. The Tesla solar shingles, there are a small handful of systems installed in Oregon. And I know that they are intending to expand their market here in Oregon. Right now, I can tell you the de facto standard for solar is the typical solar panel, not the shingle. It's possible that would change in maybe a few years' time, maybe less, maybe more. But right now, it's very early. There are very early adopters adopting solar shingles on kind of an experimental basis in Oregon. So I can't say I would necessarily recommend it in your situation for that reason. However, you could keep your eye on it. Ed, you asked, could you talk a bit about energy storage and batteries? Is it best to add at the time of solar panel installation? Great question. So energy storage is an incredibly hot topic. It's something that I talk about a lot. And is increasingly adopted in Oregon. Even a few years ago, it was being adopted very, very slowly. And just over the past year or two, that has really seen an uptick. And partially that's because people are more cognizant of energy resilience threats from wildfire and things like that. We had a really bad wildfire season in 2020. Energy storage, there are a handful of really great options for residential and commercial energy storage. They, of course, cost extra, and batteries, unless you're enrolled in a very, pretty selective battery pilot program, but a really great battery pilot program with PGE. Unless you're in that program, and that's really for very specific parts of Oregon. There's no way to really monetize batteries and their value to you. So that's one aspect of them. In terms I would say batteries are most frequently adopted right now for people who are at the end of the line on the utility grid who experience frequent outages, or for kind of mission critical things, including refrigeration for perishable goods for a small business like a brewery or a cannery or something like that. Though homes are installing a lot of batteries, is it best to add at the time of solar panel installation? That is a great question, and I cannot speak definitively. I can tell you that solar contractors are learning how to install batteries, and batteries are more complex than solar to engineer and to install. I think that my gut would be, if there's an advantage either way, the advantage is to add them at the time of solar panels, because then you can design them knowing how they're going to be charged with those solar panels. But it is complex, and I think you can add batteries to a solar system after the fact, and that is not terribly uncommon either. Colleen, you ask, are roof reverberations or new roofs eligible for tax credits? That is an excellent question. The answer to that question is a matter of tax law. And I am not a tax professional and cannot give sound tax advice. And neither, for that matter, can solar contractors. So there are differing opinions on that you will hear, I think, potentially in the solar contracting world. And the conservative answer, and again, I cannot give tax advice, but the conservative answer is no, they're not eligible. And if you really, really are keen to try to get that to be eligible, your new roof to be eligible for tax credits, definitely, I can't give you advice, and definitely you should talk to a tax professional. Jevin, I hope that I'm pronouncing that all right. I live in an all-electric manufactured home. Awesome. Are manufactured homes okay for solar panels? Are 6 panels the average consumers usually purchase? So the average that I mentioned before is 6 kilowatt, and that is going to be more than 6 panels. Panels come in a range of power output, but you might see a 350 watt panel or like a 400, maybe even 425 watt panel. So there's going to be more panels to hit that average 6 kilowatt system size. It might be more like 18 panels. And are manufactured homes okay for solar panels? It is a great question, and it is one that I know there are folks with that expertise. And I believe that there are some additional considerations, and the best source of information will probably be, as usual, a solar contractor, a highly rated solar contractor in your area. And I can't remember if some of those constraints might be because of the structural aspect of a manufactured home, but I would encourage you to reach out to an Energy Trust trade ally contractor and ask them that question. Sorry, I couldn't give you an answer there. And Mopsy, how long do typical solar panels last? That's a great question. Solar panels, so the first solar panels that were produced are still spitting out juice. The solar panels are warranted in their standard warranty length is 25 years. However, the industry has grown so much in 25 years, there aren't a whole lot of solar installations, commercial, for homes and businesses that are 25 years old. So in terms of how long do they last, that is an ongoing research question. The belief, because some of the old research solar panels have lasted so long, is that solar panels that have been installed by commercial contractors also last for a considerable amount of time. I think, you can reasonably assume 30 years, maybe more. They do degrade at about 1% of their output per year, but they still can spit out a significant amount of juice even after that 30 years. And Ed, you're asking, are Chinese versus US manufactured panels, is there a quality difference? That's a great question. So first off, we're brand agnostic, and I won't get into recommending specific brands. However, in terms of panel quality, there are a number of Chinese manufacturers. There's a great variety of Chinese manufacturers, as well as South Korean and I believe Taiwanese, and Japanese and Canadian and American. Though China does have a number of manufacturers. You'll probably find a huge range. Because there's so many Chinese manufacturers, you'll probably find a greater range of quality among Chinese manufacturers than in any other country, just because there's more of them. So I can say you can probably buy a pretty bad Chinese solar panel. However, there are brands that are very standard products that are well trusted, that are made in China. Some people prefer panels manufactured in a specific place, but talk to your contractor and they'll be able to walk you through specifics on quality and price trade-offs on different modules. So that's the last one I see in the Q&A box. If you do have a question, you can put it in there. I think there might have been a couple of questions in the chat, which I'll get to here. Julie, do the examples, and I think you're talking about the example budget slides that I showed, use the max incentives? And the answer to that is yes. And that is because we assumed a 6 kilowatt size system, which is the average. And the only incentive that is dependent on the size of the system is the Energy Trust solar within reach incentive. So that's that income qualified incentive. And that is a, at a $1 per watt rate up to 6 kilowatts, which is the max. And that's the average size of system installed in Oregon. Looking for question marks in the chat. I do see one last, maybe last question in the Q&A box now. Do the panels need to be cleaned frequently? And if so, how is that done? That's a great question. So if you're in a particularly dusty environment, say you're living right next to a construction zone, or you're in the desert and there's just happen to be a lot of dust, you will find that the dust will slowly accumulate, and that will slowly start to impact the amount of electricity you're producing. If you're in the rainy side of Oregon, you might find that the rain consistently cleans your panels, sometimes enough that you don't even need to wash them at all. If you do live in a dusty environment, or if you live where it's not super rainy, it is recommended that you take a hose, or you can increasingly hire somebody to go up on your roof with like a squeegee and a bucket and wash your panels once a year. That's typical, which is, unless a component fails, the only maintenance that is routine on solar panels, which is really great. All right. Seeing no other questions, I'm going to go ahead and wrap it up here. Thank you so much, everybody, for joining us. I am here to answer questions and be a resource for you on your solar journey. So please feel free to contact me. That's my email, zachs@solaroregon.org. Again, you'll get a recording of this webinar in your inbox. And don't be a stranger. Come to future events and let your friends and family know, and hope to see you again soon. Take care.